Hello, everyone, and welcome to. Oh shoot! I didn't mute myself. Ah, I'm so bad. One day I'll get a hang of this streaming thing. I promise. Um, how's it going? Snow today. That was a fun surprise to wake up to. Couple an inch or two on the ground. Hi, Naya. Boo, says Naya about the snow, I'm guessing. Well, everyone always forgets that it always snows in March-ish. Sometimes it'll snow in April. Wait, Jack, why are you in here? This is AP. Hopefully you caught the honor streams, that Jack. Side note, no stream tomorrow for AP. Hi, Jack. So I figured I'd just give you guys some extra time to if you wanted to take the test. So we'll use that tomorrow if you want to use that. And I've got to run by the school and get some stuff printed and do some things. So figured I could do that tomorrow morning. Yeah, so yeah, they are going to get a ton of snow. So David, I hit this. I am a little. I've got a little bit of a cold. Okay, so channel points. So because I've been streaming on Twitch for so long, and I hit this breakpoint. It's called affiliate status. So now I am Twitch affiliated, which means I get all these fancy, cool perk things. One of them being channel points. And so I actually have like emotes and subs and all these other crazy things that we can do, but you don't have to worry about any of that. It's just random other things. Yeah, Twitch is gonna pay me them big monies, like $1. Yeah, we beat Provo yesterday 2-0. There were some pretty good matches. We don't know who we're playing next week yet. We need to play Park City yet. They're one of the schools we haven't played yet. We need to play Park City and Skyridge and a couple others. Yeah, you basically just randomly accrued points for watching the stream, and then you can use those points to highlight your message. It's nothing really. Yeah, no, I am feeling a little sick. I've got like a stuffy nose, and I was feeling a little achy yesterday, but I was tired. Ah. YouTube was being annoying. Yeah. Caden, I'll give that to you later. Don't worry about that right now. Remind me later, and I'll put it up. You basically just go into the schedule, and you can see like if you click on the Clark or Park City, you can see their latest games, and you can find their picks and bans. So I'll send the link in there. Yeah, I'll look at it later. I'll send it to you guys so you can know. Yeah, Clark's they're the TP barrier top lane guys, but that's esports. We're talking about AP chemistry. Okay, what do we got? What questions do we have? I guess we can dive into the review. So those of you that have started the review, I hope most of you have started the review. Any questions on the review? My very thorough review. Isaac says nope. He's got it all checked, 100%. Well, Isaac, you can just leave. Gotta get that ad review. Give me them Twitch Prime subs. Oh, you haven't started yet, Isaac. Come on. I guess maybe we should have just not done a stream today and done the review stream tomorrow, but whatever. It is what it is. Yeah, if you guys don't have any questions, this is going to be really short. No, I don't blame you. You guys have a lot of stuff going on. There's definitely a ton of stuff going on. Is it really? Max's highlighted message. I don't think it's. It doesn't seem like it's. Maybe reload the stream, Isaac. That might help. Okay, so you don't actually have to have the review done, DJ. It's for you and your benefit. I'm not going to grade it, but the test needs to be done by Sunday night. Mary, what are we doing after this chapter? We are going to start reviewing for the test, I guess. We're going to start practicing. I don't know. So I can go through one of the short answers, Sammy. Let me answer Mary's question. So it's going to be, so as far as we know about the AP test right now, we know that they're going to do a shortened and it'll only be short answer. So I have a ton of past short answers, and so I might just start like giving you guys short answers. No. This is just for this chapter we've been doing, DJ. We haven't started into like full AP review yet, which we'll actually be able to start into that next week. So I think no stream tomorrow. On Friday, I might just like publish a bunch of stuff, like a bunch of past short answers, and have you guys kind of look through them and see where we're at, see what we can do. And then next week we'll start reviewing topics and do some other things. So, yeah. I have no idea, Mary. I don't know what College Board is doing. I think they're just kind of all over the place. Yeah, no, I won't put like a ton of assignments in Canvas, Isaac. So with the Rubik, still do the review books. You still want to have it done by the test. I think my plan is, I hope, this is me hoping, that we actually can be back at school May 4th. And so then you guys can get those review books in and done. So we've covered the entire content of the course. The only thing we haven't done, yeah, no stream tomorrow, David, sorry. The only thing we haven't done is electrochem. So if you see anything that talks about like voltages or current or things like that, you can just ignore and skip those problems. But you should know how to do everything else. So review book, I would get one as soon as possible. Yeah, Caden, I don't know. Caden, stop trying to hijack my stream. Well, that's when we'll potentially be back in school. I don't think we'll... so May the 4th is the potential day back in school. I don't know if that's when the test is actually going to be. We'll have to see. I love having brothers in the chat. All right. I missed a couple things. So when do you need to review by? As soon as possible. At the latest, I would say get it over spring break week. We are still having school through next week, but then the week after is going to be spring break. We are taking a break. We're not going into it. We're going to have a full week off. Yeah, okay. So back to Sammy's question. She just wanted me to go through one of the short answers on the review. So let's do that. We can do... I don't know, maybe the last one? Look at 94.6. I don't know which one's the hardest one because I don't remember the problems. You can tell me which one's is the hardest one, Lauren. This one's all qualitative. This one seems pretty qualitative too. This one's a little more quantitative, so I think this third one might be the hardest one. So let's see if we can do this one. I know most people haven't started. It's fine. So I'm just going to go through this third and final problem, 94.6. It's the last short answer on the review. You guys go ahead and start the review. I'll be able to answer questions this afternoon in the Discord, or I'll be available tomorrow afternoon in Discord too. But I do not plan on streaming tomorrow. So keep that in mind. All right, so let's see if we can do this problem. Let me make it small enough. All right, so we say we've got this reaction. They say, will I stream Friday? Yeah, I'll maybe do a short stream Friday just to show you guys everything that I've uploaded onto Canvas, and just kind of talk about some expectations for the reviews. We need to do that too. We'll probably do, maybe we'll do that Friday as well, Isaac. Maybe on Friday we'll go over the last quest and talk about expectations of the future. Yeah, let's do it Friday. Let's do it Friday, Lauren and Isaac. So we'll go over the quest on Friday. I'm glad you have 80 channel points. All right. So let's see. So 298, the standalone entropy change for the reaction is negative 145. Okay, so we know that delta H is negative 145 kilojoules per mole. Okay. Predict the sign of the entropy change. Explain the basis for the prediction. Okay. So if we look at this reaction, as I look at the reaction, I see I've got two gases plus another gas breaking down into three solids and two gases. So the idea that we have three gases turning into two gases. Counting up your gas molecules is the best way to predict entropy changes. Because we're going from three gas particles, gases have the greatest entropy by far. So because we're going from three gas particles, it's at the bottom of the chat. From three gas particles, we go to two, so we're losing gases, so we're becoming more ordered, and so our delta S is going to be negative. Right? Because that means it's more ordered. And again, the way we predicted that is that we have three gases to two gases. Okay, so that's our first question. Right, there's a bunch of room that we don't actually need. Okay, so part B then asks, at 298 Kelvin, the forward reaction, i.e. towards the right, is spontaneous. What change, if any, would occur in the value of delta G for this reaction as temperature is increased? Explain your ideas using thermodynamic principles. Okay, so we know delta G equals delta H minus T delta S. In this case, my delta H is negative, and my delta S is negative. And so that turns this into this turns into a positive, right? So this whole term altogether turns out to be positive. So I'm just going to go ahead and write them as positive. And so as the temperature gets higher, this positive term starts to take a bigger effect, which means the reaction gets less spontaneous. So what change would occur in the value of delta G? Delta G would become more positive. Right, and the reason why it becomes more positive is because both delta S, let me fix these signs, right? Both delta S and delta H were negative. And because we have a minus a negative here, as the temperature gets greater, this term becomes more positive. As this term becomes more positive, delta G becomes more positive. My daughter's banging on the door. Okay, letter C. Maybe after we finish this problem. Letter C says, what change, if any, would occur in the value of the equilibrium constant KEQ for the situation described in B? Okay, so let's think about our equilibrium constant. So we know that delta G naught equals negative RT ln of K. So as delta G becomes a more positive value, that means the reaction is becoming less and less spontaneous, meaning it's instead of shifting and favoring the right side of the reaction, it's shifting and favoring the left side of the reaction. And so as we shift and favor the left side of the reaction, K, because K is products over reactants, K is becoming a smaller and smaller value. So K gets smaller. Right? There's kind of a logical progression that you guys have to be able to understand and follow. So as delta G becomes more positive, K becomes smaller because of this negative sign. As G becomes positive, K gets smaller because we get more reactants. All right, letter Z. The absolute temperature at which the forward reaction becomes non-spontaneous can be predicted. Write the equations used to make the prediction. Why does this equation predict only an approximate value for the temperature? Okay, so we can predict the equation that it becomes non-spontaneous is we can just plug in 0 for delta G. 0 equals delta H minus T delta S. So we actually could solve for it if we wanted to. Let's go ahead and do that. So 0 equals negative 145 plus my temperature, minus my temperature times, we don't know delta S, so we can't actually solve for it. So it's some negative value. So we know that we would use this equation to predict it. And the reason why it's only an approximate value is because technically delta H and delta S are standard. So when we use K, is delta G 0? Yeah, delta G is. Not delta G naught, but delta G. I'm really bad at writing in the knots when I'm supposed to have them in. So yeah, if you use K in this equation, the value at delta G is 0. What did I write as my answer to D? We assume that delta H and S don't change with temperature. It's not a perfect assumption, which is true, because they're only standards for at 25 degrees C. Yeah. Okay, cool. Because you guys haven't really dove into this review yet, it's kind of hard to answer questions because you guys don't have any questions. I probably should have prefaced this a little bit more, telling you that we were going to be going over the review today. Oh, sure, Naya. So letter C, what change in any will occur in the equilibrium constant? Okay, so let's think about our equilibrium reaction. So our reaction here, right, is this idea. 2H2S plus SO2 makes 3S and H2O. So if this reaction has a negative delta G, that means the forward direction is favored. If the forward direction is favored, that means that we have more products than we do reactants at equilibrium. Okay. If delta G is a very positive value, that means the reverse reaction is favored, which means the concentration of my reactants will be greater than my products. Okay, so if delta G is a very negative value, K is very large because we have more products and fewer reactants. If delta G is a very positive value, then K is very small because we have more reactants and fewer products. And so as the value of delta G becomes more positive, K has to become smaller because delta G becoming more positive is like we're shifting the reaction towards the reactants, and so K becomes a smaller value. So, does that make sense, Naya? I think I did a better job explaining that. Okay, perfect. Cool. I'll let you guys spend some time today going into the review. Dive into the review. Ask questions in the Discord this afternoon. Ask questions in the Discord tomorrow afternoon. Yeah, I'll text my wife, see if she wants to bring them in. I think they're right outside the door. Maybe I'll just go grab them. Can you say hi, Claire? Look up here. Can you say hi? She's not feeling good. What? What? Figuring out some chemistry? Yeah. Hey, come back. Whoops. Okay, go get Mom. Yeah, we're calling the pediatrician to see what if they need to do anything. Okay, can I explain why 3 is G? Okay, so problem number 3 is essentially equal to the enthalpy when both reactants and products are solid. Oh, okay. So remember, if both reactants and products are solid, then delta S is going to be a very small value. If delta S is a very small value, then essentially delta G equals delta H. No pen. No pen. You like to write on walls. Yeah. Okay. So, Haley, does that make sense? So when both reactants and products are solid, the change in delta S becomes really, 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 really small. When delta S is really, really, really small, then delta H equals delta G. Okay, cool. All right. We'll go ahead and end the stream here. Cool. Yeah, I know she went. No, she's gonna turn off my computer. Oh. Don't turn off my computer, silly. Come here. All right, I'm actually ending the stream now, so because she's gonna turn off the computer. All right, later, guys.